We are now looking at a teaching video on simultaneous equation. So for part 1, we are looking for solutions through the matrix method. So there are some results which are very important. Part 1, we have the inverse matrix of A multiplied to A. So I will get an identity matrix. So what that means is a matrix, which is a 2 by 2 matrix with elements 1, 0, 0, 1 in it. The property involving the identity matrix is such: if I have a B matrix multiplied to the identity matrix, I'll get back the B matrix. Next, with this result that I have, I get an identity matrix there. So that will give me the identity matrix. So when you have the identity matrix multiplied to this matrix, I'll get back the 2 by 2 matrix A, B, C, D. Next, this is not modulus A, this is not the magnitude of A, this is simply the determinant of the matrix A. So this is how we do it. This is the leading diagonal. The product of these two elements will be AD, then minus, this is a receding diagonal, there are two elements there. The product of the two elements will be BC. So the determinant of the matrix A would be AD minus BC. Here I have the matrix A. In order to find the inverse matrix A, then I'll take the 1 over, or the reciprocal of, the determinant of matrix A, AD minus BC, times the rearrangement of the matrix. In the leading diagonal, I have these two elements, AD, and I will switch the places. Instead of AD, it will be DA. DA. Next, in the receding diagonal, I have BC. I will change the sign of these two elements. So I have negative B, negative C. And this is still a 2 by 2 matrix. 2 rows and 2 columns. Next, in part B, we are looking at the matrix method. This is a typical question. Now, 2 linear equations will be given. But first of all, we got to check that the x terms line up, the y terms line up, and on the other side of the equation, the constant terms line up. Then we can change these linear equations into the matrix equation. It will be like this. Take the coefficient of the x and the y. So I have 2, 3, 3, negative 1. Multiply to this matrix, xy, equals to 1, 8. Now, this matrix equation is written this way because of the way product is dealt with in matrices. If you look at the row here, the first row, I have 2, 3. It's multiplied to the column in the second matrix. 2 times x is 2x, plus 3 times y, I get 3y, equals to 1. If I look at the second row, I have two elements here, 3 minus 1. Row, multiply the column, 3 times x, I have 3x. Then minus 1 times y, I have minus y, equals to 8. And then I will go on using the inverse matrix of the matrix over here, 2, 3, 3 minus 1. The reason I pre-multiply both sides of the equation by the inverse matrix is to get rid of this matrix here, so that I'm only left with this matrix xy. So to begin with, I take the reciprocal of the product of the leading diagonals, or the product of the elements in the leading diagonal, negative 2, minus the product of the elements on the receding diagonal, that's 9. Switch the places of these two elements on the leading diagonal, and then change the sign of the two elements on the receding diagonal. Times the original matrix times the 2 by 1 matrix xy. And on the other side, I will also have 1 over negative 2 minus 9 minus 1 minus 3 minus 3, 2 multiplied to the 2 by 1 matrix 1/8. Now, without even working out in full, the result for this will surely be an identity matrix. So that will give me just the xy, the 2 by 1 matrix. Here I have negative 1 over 11. Multiply the row to the column, I get negative 1 minus 24. And here, negative 3 times 1 is negative 3 plus 16. So negative 1 over 11 times, adding these two up, I will get negative 25. Adding these two up, I get a 13. So the x, y is equals to 25 on 11. The other one is negative 13 on 11. To simplify that, I have 2 and 3 over 11. Here I have negative 1 and 2 over 11. So the x value is just that, the y value is this, negative 1 and 2 over 11. So this is using the matrix method to solve for x and y. Next, we look at solution by substitution method. Of course, when we have type A, a linear equation and non-linear equation, only the substitution method is workable. So the other method, of course, is elimination method. That cannot be used. And previously, we also looked at the matrix method. Matrix method is only workable with two linear equations. So in type A, we have a non-linear equation that actually just constrains us to the substitution method. So for this particular question, the first equation mentioned there is a curve equation, which is the non-linear equation. The second one is a linear equation. The reason is this. If we look closely at that, it has the form of y equals mx plus c, and therefore it is a linear equation. Now we will start with the linear equation, that is to make y the subject because the coefficient of y is 1. So I have y equals to 1 minus 2x. I call it equation 1. Then the other equation I label as equation 2. So the substitution of the expression of y into the equation 2. The y now is replaced by 1 minus 2x bracket squared plus the 2x plus 3 squared equals to 10. Expanding this, I will have negative minus 4x plus 4x squared plus the 4x squared plus the 12x plus 9 minus 10. What I've done is to transpose the 10 to the left hand side. These two like terms add up to 8x squared, and I have 12x minus 4x giving me 8x. Then 1 plus the 9 is 10, 10 minus 10 is 0. Here I can take the common factors 8x out. I have x plus 1. There are two factors, 8x and x plus 1. So 8x equals to 0 will give me x equals to 0. X plus 1 equals to 0, I'll get x equals to minus 1. Here, because I'm looking for the coordinates of the 2 points A and B, I will have to substitute x equal to 0 into the first equation. So when x equals to 0, y will become 1 minus 2 times 0 is just a 1, and that will be the b coordinate 0, 1. Then next, I have x equals to negative 1. Put that result into the first equation. I will have 3. So point A is negative 1, comma 3. So this question is solved already. But first of all, the linear equation is rearranged such that either the x or the y is a subject. So whether we choose x or y as a subject all depends on the coefficient of the two variables. Of course, we give preference to the coefficient that is 1. So in this case, y is chosen to be the subject of the equation. And then we substitute this expression of y into the nonlinear equation. Usually, a quadratic equation will be formed such that we'll get 2 values of x. And then we will have to find the 2 corresponding values of y. And also the naming of the points. You notice that I call these coordinates point B. The reason is that that value of x is bigger than that value of x. So A with a smaller x value, B with a bigger x value. For part B, we are looking at simultaneous equation involving indices. By that, we are talking about this sort of equations. But you can see that we can make the basis the same. Like in the first equation, I can make 9, 3 squared. So I have 3 to the power of 2y. And 27 is just 3 to the power of 3. So using the index rule, I have 3 to the power of x minus 2y is equals to 3 to the power of 3. Since the bases are the same, then the integers are compared. So I have x minus 2y equals to 3. So x is equals to 2y plus 3. So first equation, x equals 2y plus 3. So the next equation, where I have 4 to the power 2x times 2 to the power y bracket 6 and 0.25. At first glance, it may not seem like they have the same basis, but they do have. 4 is actually 2 to the power 2, so 2 times the 2x is 4x. And then I have the product of the two integers, so 6y. This is just 1 over 4. 0.25 is 1 over 4, and I can change it to 2 to the power negative 2. Since this is the product involving two bases of the same, then I add the integers together. And since the bases are the same, I can compare the integers. Dividing throughout by 2. And I label it as equation 2. In this situation, both these equations are linear equations, and therefore we have a choice of perhaps using elimination method or even the matrix method. But since we are looking at this group of questions using substitution, we stick to it. So substitute equation 1, or the expression of x into equation 2. So 2, the x is replaced by 2y plus 3. Plus 3y equals to negative 2. 4y plus 3y is 7y. And here 2 times the 3 is 6. Transpose that to the right, I have negative 8. Okay, there is a mistake here. Dividing throughout by 2, that should have been just minus 1. So sometimes when the answer is not too nice, just look up a few lines, have a quick check, and normally you can see the numbers are pretty decent. So I have a negative 1 here. So 2 times 3 is 6. So transpose that to the right side, I have minus 1, minus 6, that will be minus 7. Therefore, y is equal to negative 1. So when y is equal to negative 1, the x value would be 2 times negative 1 plus 3. I have a 1. So this is the solution for the equations involving integers. So you can see very clearly from the start, we convert such an equation to a linear equation involving x and y. And also, the other equation involving integers, we change to a linear form. That will be the easiest way to deal with such a question for the x and the y values. For type C, we are looking at simultaneous equation involving the logarithmic form. You can see here that first of all, this part we have to show as this expression on the right side. So what I do is to begin with that, because I believe that the subsequent parts will be related to it because of the word hence. So log base 16 xy. And you can see over on the right side, all the bases are base 4. So what I need to do is to perhaps split it up first. Log base 16x plus log base 16y. And to change that to log base 4. So if I do that, it will be log base 4x over log base 4 16. Here, log base 4y over log base 4 16. So this is 16. 16 is 4 squared. So I will have log base 4 x over 2 log base 4 4. The square here that makes 4 squared 16 is transferred to the multiplier place. And here, that expression will just be the same as that. And log base 4 4 is just 1. So overall, the expression should be half log base 4x plus log base 4y. So that expression ought to be in a bracket. Hence solve the simultaneous equation. So the first one is log base 16xy equals to 7 on 2. So if you look carefully, that is a left-hand side expression. I can actually change it to half log base 4x plus log base 4y is equals to 7 on 2. So both sides multiply by 2, I will have log base 4x plus log base 4y equals to 7. So that will be the first equation. But I can make log base 4x the subject, then I will have 7 minus log base 4y, equation 1. As for the next equation, log base 4x over log base 4y equals to 3 over 4. Now, I call that equation 2. If I replace this with 7 minus log base 4y divided by log base 4y is equals to 3/4. Cross multiply here, I get 28 minus log base 4y equals to 3 times log base 4y. If I group these two terms together, I will have 7 log base 4y equals to 28. Log base 4y would just be 4. So this is the base, this is the index. So y is equals to 4 to the power of 4. And that will give me a result of 4 to the power of 4, 256. So with this result, I can then substitute y equals 256 into equation 1. So I have log base 4x equals to 7 minus the log base 4y is just a 4. So I have a 3 here. This is the base, this is the index. So x is equals to 4 to the power of 3, which is 64. So the x and y are solved. So there are times when students just stop at log base 4y and also log base 4x for their answer. But it should be to find the x and the y value. And we have used the result in the first part, the showing part, in simplifying the first simultaneous equation. And after that, we make use of the substitution method. Now we look at part D, or type D, simultaneous equation involving trigonometric forms. So the sine theta comes in, cos theta as well. So for part A, we have to show that that will give me sine squared theta. So I'll start off with the left-hand side, which is just 2 times a squared minus b squared. If I just factorize that, I get a minus b, a plus b. And the a minus b is replaced by cos theta, and a plus b is replaced by sine theta. So I have 2 sine theta, cos theta. That, using the trigonometric identities, will reduce to sine 2 theta, which is just the right-hand side expression. Proved or shown. Now, having done that, we move on to B to find the value of a squared plus b squared. The a squared plus b squared is actually just a plus b, and if I just expand that, that will give me a squared plus 2ab plus b squared. And if I just take away a minus b squared, or plus, then I will have a squared minus 2ab plus b squared. So you can see, if I just add these two up, the middle term will get cancelled off. What I do have at the end is a squared plus a squared is 2a squared. B squared plus a b squared there, I will have 2b squared. So I would still have to divide this expression by a 2. But you can see what I've done here. the a plus b is sine, but when I square it, I get sine squared theta, and a minus b is just cos theta. Square it, I have cos squared theta over 2. Using one of the identities, the sum of these two terms will be a 1. So overall, the result is just half. So you can see, in many ways, we are doing substitution, but involving the trigonometric expression. So for part C, find the value of tangent theta. Well, tangent theta is actually equals to sine theta over cos theta. And for sine theta, I have a plus b. And cos theta is a minus b. So using this result, a over b is equals to 3. I make a the subject in this case, so I have 3b. A is equal to 3b, and I substitute the 3b into the a and the a here. So I have 3b plus b, and I have 3b minus b. This result will be 4b over 2b. When the b is cancelled off, I have 4 on 2, which will just give me a 2. So you can see subtly this type of question is about substitution as well, but put in a subtle way without the word simultaneous equation. So we have come to the end of this particular video segment.